I spent 3 days debugging a scraper that I really expected to have knocked out in maybe an afternoon. And at one point, I had four AI models open simultaneously, all confidently giving me an answer that did not work. And I eventually fixed it by thinking manually like the old days. JobOps is a self-hosted job searching application that I built because I was tired of manually checking job boards that quietly delete listings, and they are across different websites and they have a different set of fields that they have. So, for example, some of them report the salary, some of them don't, etc. JobOps scrapes 8 international and UK specific job sources, so LinkedIn, Gradcracker, Indeed, etc. Normalizes the results and then it stores them so I can search for them. I can generate tailored resumes for them. And then after that, I can track them automatically using my email to see which ones that I applied to got rejected or accepted. It has over 2,400 stars on GitHub, so that must mean that other people have had the same problem that I encountered. Most of the sources that I had were relatively easy to add. A couple of them took an afternoon, but one of them took the better part of a week, and it is still the scraper that I trust least. That one is Gradcracker, which is the main UK kind of graduate job board for engineering and technology. And adding this source taught me more about the Crawley framework than anything else in JobOps combined. So today I'm going to discuss that story. So the first thing you notice is that Gradcracker is very serious about bot detection. So a basic request just gets rejected anywhere. So you need a full browser and it needs to behave like a real browser. So I used Trolley because I've used it before and I thought it was a fairly natural pick for this kind of setup. The queuing system was fairly natural to me because it kind of just clicks mentally in my head. So I didn't want to be fighting the scraper itself. I just wanted to be doing the scraping itself. So the flow that we went with was we go to the search page first, and then from the search page, we look at all the job listings. We get the link to each of the job listings, go to that link itself, then find the apply online button at the bottom, then in-queue that URL, then scrape the application, so the future URL that it goes to after clicking the apply online button, not just the Gradcracker link, and then hit the next page on the job listing page, and then keep going until all the required pages are done. This wouldn't have been impossible in just plain Playwright, but it's just a lot nicer to have that mental model of queuing and unqueuing in Crawley. So the naive approach would just be to use a standard Playwright crawler, which got me up and running fairly quickly, and it just worked, right? So you can get the list pages and you can get all the links working, and it worked. The first one pulled data. I was very happy. But then Gradcracker started pushing back. So the initial version that I had, just the Playwright version, it didn't have any bot avoidance. So what I realized is that it would just give me a CAPTCHA. Sometimes it would give me a blank page. Sometimes it would just give me a 403 and nothing would be served to the browser. And it was unpredictable. The fix I found was swapping in CamuFox, which is a Firefox-based fork of Firefox, which is built specifically for anti-bot detection. So instead of using Chromium, it uses Firefox with actual humanized behavior and randomized fingerprints and spoofing geolocation baked into it. Combining this with dropping the concurrency down to a maximum of 2 and adding a bunch of delays between the requests means that the flakiness mostly went away. There was still one problem. The apply button that we had at the end doesn't navigate in the tab that you're already on. It opens a new tab. That's fine because CamuFox supports the new tabs, so you can switch the context to a new tab and go there. Except that the Gradcracker website didn't open a pop-up reliably. So the button has some kind of randomized delay, so you click it and then you wait. It could be half a second, maybe longer. Then a new tab spawns. It bounces through several analytics URLs and then lands on the actual application page, which would be the URL of the employer's ATS, which we would want to capture. The problem is that the several links or several URL changes I mentioned is doing a lot of heavy work. It's not a fixed number. So it could sometimes be 2 redirects, sometimes it could be 10 redirects. We just don't know, right? And most of the AI suggestions that we had made the same assumption that the navigation had a predictable number of milliseconds that we could wait, or a specific number of requests that would be made, or a number of changes of the URL that would be made. And not Opus 4.5 and not Codex 5.4, no one could solve this problem until I worked out the problem myself. And the solution that I came up with is embarrassingly simple. Instead of trying to predict when the navigation is done, we just poll the URL every 100 milliseconds and wait until it hasn't changed for 300 milliseconds, which is 3 different checks. So if it hasn't changed and we are not on the Gradcracker page, that's it. That's the final application URL. And this handles all the cases of how long it is, because the URL keeps changing, but we keep polling. It handles the navigation event. It handles browser requests. It handles URLs changing for like a bunch of different times. So the whole solution of the whole thing was adding a while loop, right? Can we just have like an old school way of doing it like a human being would see it, for example, right? So the scraper works and it pulls real data and the redirect bug is solved. It is now integrated in JobOps and it now works. But I mean, in my opinion, slow and reliable beats fast and blocked every single time. So every delay I baked in is, I suppose, me not wanting Gradcracker to challenge me. So it's not elegant, but it works a lot more than the alternative, which would be not working at all, for example, right? A solution that I could implement to fix this problem would be rotating my proxy. So the concurrency cap, if we ran every single browser with a different proxy, so a different host IP address is sent to Gradcracker, that would improve things, I'm guessing, slightly, but I just don't have the budget for it. And so I instead just handle a slower scraper and hope for the best. The main takeaway from all of this is pretty simple. So scraping frameworks rarely cause the worst pain. The websites themselves do. Crawley handled the structural complexity really well, and most of my time was spent with Gradcracker's quirks and the bot detection itself, not the framework itself. But that's what you want from a framework. You don't want magic. You just want less wasted engineering effort on the plumbing so you can focus on the actual problem. And the actual problem in this case was a while loop that I should have written on day one.